one more time. I'm not sure if this is working. I'm just on my cell phone here. I think the data at the tower site is a little flaky here. I'm just trying to show I'm getting ready for the NavCom test for the radio station, my radio station, CJFL-FM 104.7 in Cochrane, Ontario here. We got licensed back in the spring. So I'm just trying to be live here. I had an earlier one and it keeps disconnecting me for some reason. The signal's not very good here, so I was just making sure that I talked for like 20 minutes, but I think it wasn't actually, I hope it was, but it wasn't, but it looks like it wasn't. Okay, I think it's working now. Hit that like button, said nice, nice. Okay, see, I was on like for 20 minutes here and I think my data was off. So my apologies if I disappear here. The data is very bad. I'm just getting things ready for tomorrow's on-air test. The government is coming over to inspect and make sure everything is according to the radio station license. So about 5-10 minutes ago, I did a tour of the tower, which is about on the other side here, which is almost 100 feet. And I was explaining the loop because we're using a non-linear polarity, right? So instead of being linear polarity like vertical or horizontal, which is very prone to reflections and refractions, a non-linear polarity like circular is not as prone to that. It has a tendency, the EM wave tends to snake around the earth more and around obstacles instead of purely refract and reflect. So in other words, just like in Tom Bearden terms, you know, by going non-linear, more interesting effects happen with the EM wave. So it's like a way of getting more distance, more range, more quality without actually having to increase the power at the antenna just by fancy geometry, which kind of lines up with the Tesla coil stuff, right, for EM waves and longitudinal setup, where there's actual documentary of that, where circular is the way to go because you have problems with like the Tesla experiments with regular linear polarity. It's very predictable, but just like in our systems, we're looking for non-linear. And the RF engineers know that, and the ham operators as well. The only downside is to using a non-linear antenna is you have to make up for it at the transmitter. So even though our license is just for 5 watts, you have to basically give it double the power so that at the antenna, because you're saturating each polarity at once, you get the same strength, you know, the same field intensity, right? So you end up bringing the, but actually you're not actually stronger, you know what I'm saying? But it's a field dynamic effect. So this is why it's very preferred in the those who know in the broadcasting field, because it gives you a much clearer signal without actually needing to have a license essentially for, you know, 1,000 watts or something like that, right? So this is what I was saying. The test is tomorrow, and they're coming here. It's the equivalent of the FCC. So I have to make sure the transmitter is putting out exactly 15 watts. So I got the bird meter here, exactly what they would be using, and I'm calibrating it to be 15 watts. So that at the antenna, we get our 5 watts ERP, which is effective radiated power output, right? So what I got now is a dummy load. This is a 50 ohm down here, a big giant 50 ohm resistor that can handle 1,000 watts. So all it is loading the RF. So we're not killing our final. We're not essentially shorting out our transistor like if you were running a Bedini, right? So this is dumping. It's like the equivalent of giving it a load or dumping it into a capacitor. But right now what happens is because we're testing, we don't want this to actually go out into an intentional radiator, into the antenna. Not right away yet. We need to calibrate. Once we know that it's all calibrated, then we can connect the antenna. That's what they're going to come and do tomorrow. They're going to take the pictures. They're going to make sure everything is right. Then they're going to look at our antenna, make sure we're at the right height. And then they're going to certify it, and then they give us our... So I was showing, there's the transmitter.